Welcome back. It's time to walk through our own implementation of hash table. Now, before we get started, I do want to mention something that you may be wondering about. That is this underscore over here. What does that mean? In most other languages, like Java, when you create a class, you can have private properties. That is, properties that I can't access outside of this class. So I wouldn't be able to do my hash table underscore hash and access this property or method. Now, with JavaScript ES6, that's not really possible. And there is a common standard, which is to put underscore here in the JavaScript world, which says this is a private property. Now, this is just meaningless, really. I can still access the hash method, but it is a developer standard in the JavaScript community to let other developers know that, hey, you shouldn't be accessing this, even though you technically can. And there are ways to make it work and have private properties, but it requires things like closures, symbols, or weak maps, which, again, is beyond the scope of this course, and we don't need to worry about. So that's where the underscore is coming from. We're not usually going to access hash function like this. All right, now that we got that out of the way, let's talk a little bit about what this does. If I enter in here grapes, we first create a new variable that is hash, that is equal to 0. And then this key, we're going to grab the length of grapes. So that is 1, 2, 3, 4, 5, 6. And we're going to add 0, which comes from the hash, plus key character code at. And character code at in JavaScript simply gives us an integer between 0 and this number, representing the UTF-16 code. So that's just an encoding. It's pretty much saying, give me a character code, because remember, in memory, a string or a letter is represented as a number. So this method allows us to say at index whatever we put in the parameter. So let's say we're looking at index of I, the very first one will be G. We're going to get the character code for G, that is a number. We multiply that by the index again, just to make sure it makes it unique. And then we use what's called the modulo operator to make sure that this stays within the length of 50, the size of our data. And then we return the hash. An easy way to see what's happening here is to simply console.log hash. If I run this, we see that it's going to loop through our grapes character by character. It's going to generate some sort of a hash. And because this hash gets constantly looped over, we include whatever the generated, let's see, the first one is 0. It's going to say 0 plus whatever this is. Then the next iteration hash is going to equal 14 and generate something else, which is 8, and keeps going until we get 23. You can take your time and go through this code if you really want to. Again, this is not the focus of this video, so let's move on. Using our hash function, let's do our very first method. Let's create the set method. This set method is going to receive a key and a value. And just so we can see this and what's going to happen, we'll run this method here saying we want grapes to equal 10,000. Lots of grapes because they are delicious. If I run this, I get undefined because, well, this isn't really doing anything. The first thing we want to do is to create a variable called letAddress, which will represent where we want to store this information. And we'll say this dot hash key. So all we're saying is store this data that we're going to insert, the key and value, in this address space that is created by our hash function. And we give it the key of grapes. Remember our little animation. We're sending the grapes into that magic little blocks. That is the hash function. From there, we simply say if this dot data address, if it doesn't exist and there's nothing there, because remember, in a hash table, we can have collisions. And because we only have 50 spaces, 50 shelves here, we might have these collisions with enough data. So we're going to check if there is nothing there. In that case, well, just simply add that data. We're going to say this dot data address is going to be an array. And in this new space, new address space, we're simply going to add by doing push key value. So let's run this and see what happens. Oh, and I have a misspelled address here. Let's run that again. I get undefined. But let's see what happens if I just console.log this dot data here. Whoa, check that out. We have 23 empty items. On the 24th item, we have grapes, 10,000, an array here, and then 26 empty items after that. Remember, we have 50 shelves in our memory, and we have 23, 24, plus 26, that's 50. Except our grapes was inserted somewhere in 50, it looks like the 24 spot. Very cool. But what happens if this already exists? If I change the hash table to just have, let's say, 2 memory spaces, and I click run here, I get 1 empty and grapes. And if I change this around, do you see that? If I click again, and let's say go back to just grapes, check out what happens to my hash table. I click run, and it just deleted my previous entry. We have a collision, but we're not doing anything about it, and we've just deleted our data. That could have been really important user data. We definitely don't want that. So in order to solve that, we simply say if, because we're checking here if there is nothing in that address space, do this. Otherwise, simply add on to that array. So we can actually just run the same command here. A nicer and cleaner way of doing this is to actually just take out the else, because regardless, we're always going to be pushing key and value. We're always going to be adding the key and value that we add to the data. So all we do is just remove this, so that when I run this, and just so we know what's happening, let's return this dot data here. I'm going to hit run. And if we add here, let's say another item, this time we'll say apples, and just 54 apples. If I run this, did you see what happened here? If you look closely, we have one empty item and then an array that contains inside of it the first index that is an array and a second index that is another array, because we've just pushed onto our existing array because our memory space is only 2. Very cool. That wasn't too bad. Let's keep going. The next one is, well, I want to grab be able to grab grapes and apples. We can use the get method here, which will receive a key. And this get method is going to work very nicely by just saying get and then what we want to grab, which will be grapes. We're going to do the exact same thing in that we run it through that black box where we're going to create, or we're going to use the hash function to get the address of where we want to go. And now we have the address to where we want to grab our information from. However, remember that we store this information in a bucket. So we have grapes and 10,000. How do we grab that? We know where to get it from now. We have the address, but we now need to loop over and grab grapes and then 10,000, or apples and then 54. Let me show you what I mean. We'll first create a variable saying current bucket. That will just be this.data or address, just so we don't repeat ourselves and we have a reference to this address or to the address and the data value. So this means if we console.log current bucket and I run this, you see that I have the current bucket. Even though this has 2 items, remember that it is technically just within its own bucket within one array. If we increase this memory space to, let's say, 50, we see that this bucket contains grapes. So we're grabbing this information, but all we want to do is have 10,000 being returned. That's how hash tables work, or the get in the hash function works. Well, all we need to do is to say if current bucket, and we'll say dot length. That is, if this current bucket has something in it, in that case, we are going to do something. Otherwise, we're going to just return undefined because there's nothing in the bucket. We're checking if this actually exists. So if there's nothing in the array, if the length is 0 and the array is empty, well then, we're not interested in it. As a matter of fact, we actually don't even need the length here because remember, initially, it's just going to be an empty array with undefined, and we add an array to each slot whenever we set something, and it's an empty address. So we can just leave it like that because if it's undefined, it'll skip over and return undefined. Now in here, we will do a for loop because remember, we might have multiple items in this bucket, like we saw when we had 2 memory spaces. In which case, let me actually demonstrate that. So we can see it. Say run. Oh, and current bucket. I can't spell. Let's run that again. All right. If we console.log current bucket and run this, we see that we have 2 items in that bucket. So we will need to loop over using our favorite for loop, which we've done a ton by now. We're going to say as long as I is less than the current bucket dot length, just increment I. And within here, this is a little bit tricky, so hopefully you follow. I'm going to say if current bucket I, which is the index. So remember, it's going to say 0, which is going to grab this, then 1, which is going to grab this. If current bucket, the grapes, so if I do 0 here, that means grab the first, in our case, the I, so it's going to be 0 first, grab this first array, then grab the 0 index within this array, which will be grapes. And then once it loops the next time around and I is 1, it's going to be apples. Check that against the key. Remember the key that we receive here that we are looking for. So if grapes, which is the key, matches with this item, In that case, just return the current bucket, the I, and 1 because we want to return 10,000. Hopefully you follow here, because if I run this, I get 10,000. The get grapes is 10,000. If I do apples here, it is 54. How cool is that? And looking at this, I hope you understand on a deeper level the time complexity implications of hash tables. Even though we're doing a loop here within the hash function, remember that hash functions are really, really fast. We're just looping over the key, so we don't consider this to be O of n. This is very, very fast. It's O of 1. When we set something, there's no loops here. We're just adding it to our data. We're just pushing it. So that is O of 1. And if we go to get, most of the time, if there's no collisions, it's going to be O of 1. And in real life, most of the time, you can consider that it is O of 1. But in our really bad example with just 2 memory spaces and not a very good hash function, well, this can become O of n. But for now, because we're good programmers, that won't happen, right? Everything will be good. We have O of 1 get. We have the for loop here that might create that list we saw in our example. See this list that we have here? This is what we created. And it would be O of n if this list just kept growing and kept growing and kept growing. But there is one other method that I want us to build and to showcase to you one other downside of hash tables. What if we wanted to go through all the keys of the hash table? How would we do that? We're going to try and implement that in the next video. Bye-bye.